Hello ROS developers, this is ROS developers live class number 80, and today we are going to learn how to program the ROSbot by Husarion. So imagine that you have bought this ROSbot and then you take it out from the box and you would like it to make it navigate around your area, your space, in just a few minutes. So that's what we are going to learn here today at the ROS developers live class. So let's start pushing our ROS learning. Hello ROS developers, this is Ricardo Tellez from the Construct. I'm very happy to be here in another live class, and today we are going to learn how to use this, and we are going to use a simulation and also the real robot. So I will show you how to control the real robot, but in case that you have also a ROS development studio account that can connect to the real robot, so let me know on the chat and then I will provide you with the code so you can control from your home, from your location, this ROSbot also. So we'll do this by the end of this live class. Okay, so then I would like to say hello to the people on the chat. I can see here the usual suspects. So we can see Derek Capu, that he's been there since some minutes ago before the class. I recommend you to come up to the chat before the class so we can have some chat and discuss some things prior to the class. And I see also Sakti Bells, who is also here all the weeks. He has a problem with the differential drive robot and turning arcs. So I can see Adam also here. Adam, nice to see you again. Astik also. And and Dominique Nova. Oh, Dominique here. Dominique is the CEO of the company that builds these robots. So welcome to the live class, Dominique. Then Matthias, Stefan Peralbo, and many others. I see that you are there, and maybe you are shy. Don't be shy. I mean, just enjoy these live classes for learning, all of us, and have fun also. So don't be shy and share your thoughts on the chat, on the chat that is beside, on the side of this transmission. But if you don't feel like, then don't worry. Just stay there and watch and take as much as possible of the knowledge that we are going to share here today with everyone. So let me go straight with the subject. So what we are going to learn today is how to build one program for this robot from zero. Okay, it's very simple one, okay, because we are going to use a lot of stuff that has been already done for ROS. Basically, we are going to use the ROS navigation stack. But we are going to do this creating a project, a ROS project from zero. We are going to test it on simulation, and then in case that you have a ROS development studio account that can control the robot, then let me know in the chat and then I will send you the code so you can connect to this. In order to connect to this robot, you only need a code, a specific code that the robot itself is going to give me. So you are going to see how everything works. Very, very simple. So another thing that I would like to tell you is that in case that you don't have this robot, you can buy it. You will have some links there. I highly recommend it because it's very nice. It's quite compact, has many sensors and actuators, so it's very nice to start learning about ROS. But also, in case that you don't have this and you cannot afford, you can apply what we are going to learn here today to your own robot, provided that it is a differential drive or and has a laser. For example, that Derek Capu there on the chat, he was saying that he also has a differential drive robot, and he would like to apply what we are going to learn here today to his robot. So that's possible. So how we are going to work today? Today we are not going to share a ROS yet. I'm going to share with you one PDF. This PDF contains the instructions to build a ROSjet by yourself. So we are going to do it together, okay? So you have to follow together with me as I am giving the instructions. But also you have in this PDF for later reference or in case that you get lost something. So you follow this PDF and then you can see the instructions about how to construct this ROS project for ROSbot. Okay, very, very simple. Let's see. Let's see that, one thing more is that in case that you get stuck and you have any problem, put your questions there on the chat and I will try to answer the questions. Okay, so I'm handling many things here. And today we have our Christian, who is the main person that helps me on the chat, but today he's a little bit sick and he's recovering, so I don't expect... Oh, yeah, he arrived at the end. Okay, so it's good. So Christian is there. So very good, Christian. I couldn't communicate with him, and then I was hoping the worst, but finally he arrived. So very good. So put your questions there, and we'll try to answer all of them. Let's go. Let me share with you the link with the PDF document. So I'm here copying, and I'm going to share this link with you on the chat. So I'm going to copy this and put it there on the chat, and then I'm going to click on it also. So I have my link here. I'm going to share with you my screen. So here you can see I'm going to put the same link I have shared with you. So I'm putting this here. And then you're going to get this PDF. It's a PDF that you can download, you can print afterwards. And it contains all the instructions for today's class. So then we are going to be constructing the ROSjet all together. So please follow me, and in case that you get stuck, let me know there. And let me know if you have any problem also getting the PDF. So I hope not. And then what do we have? So we have here one error. The live class is number 80, but here it says 79. So, okay, yes. This image then in the future, when we are very famous, this will be very valuable because it will be the, the image that contains an error. Oh, yes, I got it, the original PDF and so on. So, yes, just keep this PDF safe in your hard disk. Okay, so if you want to know more about this robot, you can have here the manuals of the ROSbot in case that you need it for your own robot, or in case that you are thinking about having it. And then for today, we are not going to program in Python or C++. We are going to use the already made code of ROS. It's a ROS navigation stack. And for that's why we only need to know about Linux and a little bit of ROS basics to understand how the packages and so on works, and also a little bit about navigation. So don't worry too much if you don't know about navigation, because we are going to use the things that are already done. Just use them. So we are going to provide you with the proper parameters. But in case that you would like to know more, here you have some courses, some online courses that we have prepared, and you can use them to get into the details of those subjects. Okay, so for that, so what we are going to do is to use the ROS Development Studio. It's the tool that we have created online, so you can practice without having to install anything on your computer. So you can use your Windows, Mac, or Linux, whatever version, and then you have to go to this direction, rosds.online, or click here. Then it's going to, so it went directly to the ROSDS, so let me right click and do open on a new tab. So if you click here, then you are going to get to the ROS Development Studio. In my case, I was working with some other projects, so it's opening me this screen, but in your case, if you start from scratch, then you should reach this page. Okay, so this is, I have many pages here open. There it is. So this is once I have logged in into the ROS Development Studio, of course. So you need to log in into the ROS Development Studio in order to create your project. We are going to create the project using the ROS Development Studio because it's easier. So you can use in any computer. So all the people that you are there, you can be practicing with me right now from wherever you are. And then, so I'm waiting for you to see if you can log in. In case that you have any problem, let me know on the chat, okay? Just remind you one thing that, so I have here my projects, of course. In your case, this screen will look a little bit different based on the project, on the ROS jets that you have. It depends on which ones you have created. But today, don't worry, because we are going to create one from zero for the ROSbot. So let's go with the project. So for that, what do we have to do? Is to create a new ROSjet. Press this button here, create new ROSjet. Just press that, and then we get this screen where it says the basic data about the ROSjet. I can see here that Merjabuth has arrived, and he says, hello everyone. Okay, Merjabuth, welcome to the class. You're a little bit late. Then go up and get the link with the PDF that we are using here today and try to follow. You will have to go to the back of the room because it's many people is already in front of you. Then let's go. So let's create this new ROSjet. What do we need to, well, specify the name. So we can say, for example, ROSbot testing for live class 80, for example, whatever you want. Then here in the choose file, you can select here in choose file one image that you would like to assign to your ROSjet. So whatever you have in your hard disk, you can use it. So let me see if I can find one that is funny here. And this is the background. No, so let me see. Yeah, let's put no, that one, no. Yeah, okay, so that one, for example. So I have selected one from my hard disk, and then that's it. Then you have to select here for which ROS configuration you are going to create your program. So in this case, the ROSbot is equipped with ROS Kinetic. So we have to select this one. You can select other, like Melodic or ROS2, even ROS2. Remember that we are going to do a ROS2 live class also with the ROSbot in a few weeks from now. But now we are going to use Kinetic, the one. Then here select a robot to program for. You can select here if you want to select to another robot, whatever the robot, then just leave new robot selected. But if your robot is inside this list, it's better that you do it because everything will be configured for that robot. So it's already pre-configured. So select the ROSbot for ROS, Kinetic by Husarion. And that's a robot. Yes, that's right. Then keep it private or public. Then it depends on you. If you are on a free account, you cannot select the private. And then description, whatever. So this is just a test with ROSbot. Then press create. And then once you have pressed create, then you will reach this place. Sorry, I selected this image, the first one that I have in my hard disk. And then, so I hope that you are here. Then you can see here on the side that there is a documentation for the ROSbot that is already created with some examples and so on. We are going to see this documentation in a few minutes. It's because it allows you to start with the ROSbot off the shelf very quickly. But what we have to do now is just open our ROSjet. So it's an empty project ROSjet of ROSbot. Actually, it's not so empty because since we have selected the ROSbot, then this ROSjet already contains this documentation that you can see here, and also contains the simulation of the robot, so ready to be launched. So that's some improvements, so you don't have to care about maintaining the simulation or looking where it is. So let's launch it. For that, select the basic CPU, 2 CPUs, basic, because for today we don't need anything else. And also for the others, maybe you don't have access, depending on your level of user, you may have some more CPUs or less. So select the basic because it's good enough, and then press open ROSject. There it goes. Then it's going to launch the machines, prepare the files, and prepare an empty project for us for working with the ROSbot. In the meantime, let me drink some coffee. And also check the question from Saktivel that says, can you please explain the ROS and ROS2? Why ROS2 born? Oh, yeah, so yeah, I don't understand what you mean by explain the ROS and ROS2. So there are 2 versions of ROS. One is ROS Classic, let's say, and the other one is ROS2. This is the newest one. And then ROS2, it's intended to be supported for, to have support for industrial and commercial applications that ROS Classic is lacking. So that's it. So ROS2 still is under heavy development. So handle with care about that. Well, okay, so we have it open. I hope that all of you have opened the ROSject and that you are in a screen similar to mine. And then, as you can see, everything is already configured for your Husarion ROSbot. And here it has opened already some documentation and tutorials that you can start doing right now. Because if you follow the instructions, you can do all those things just right now. Everything has been prepared for you already. Okay, but today we are not going to work on that material because we are going to create our own program, and we already know all this documentation, don't we? Yeah, I'm sure that you already know everything. So you can have a look afterwards at this. So we can close it by clicking here on the arrow. And in case that you want to check afterwards all that documentation, where is it? Where can I find it? Very simple. Go to Tools, then select Jupyter Notebook, and then finally, when this opens, so there it is. So you get the information here. Okay? So don't worry that you are not missing anything. Okay, so let me go with the instructions that we have on the PDF so I don't forget anything. So we have done all this part about the preparation of the ROSject and launching. Okay, so now what we are going to do is to create, we want to build an application that it's a patrol robot. So a patrol robot is a robot that is working with is in an environment, moving around the environment, and then trying to detect objects that it recognizes and people that is allowed to be on that area. And then when something strange happens in this area, then it's going to fire an alarm, for example. So in this live class here, we are going to work only in the navigation thing. That is about creating the map and then making the robot move autonomously on this map, around this map. And in another live class that we are going to do in 2 weeks from now, or 3, I don't remember exactly. So we are going to use DARNet, that is a deep learning system for using neural networks to recognize objects. So we are going to apply this to the robot, and we are going to use the map that we have created today. So that's going to be in 3 weeks from now. So don't worry, for today, let's go and let's continue with the ROSject that we want to create. Then, let me see, let me check that everything is correct. Yeah, so, then the thing that we have to do is to create a package that is going to contain our code. How do we create a package? You know, catkin create package, then the name of the package. Let me put it a little bit bigger so you can see this better. Yeah, so this is catkin create package, that's the command, then the name of the package, and then the dependencies. So, but remember that this package has to be created, this command has to be issued inside a source, inside a Catkin workspace slash source. So you cannot create this wherever. It has to be in a Catkin workspace slash source. So we are going to create two packages, okay? So the first one is the one that is going to contain the ROSbot patrol, and the second one is the one that is going to contain the simulation with all the environment that we are going to use to patrol in the simulation. So this ROSjet already contains some simulations already made, but we wanted to provide more entertainment, you know, to learn more things. So that's why we are going to create a very simple simulation, very simple. So let's go on, let's create the packages. So the first one, it's control. We are going to create a package that is going to move the robot. This is a program that has to run inside the robot. Because of that, we have to put it here in the ROS.ds inside the Catkin workspace. So let me show you where. Okay, so first let's go and open the IDE, the development environment. For that, you need to go to Tools and then select the IDE tool here. Here, you can see all different workspaces that your ROSjet, this ROSjet that we have created, it's organized. So it contains different workspaces. So you have to organize your code, okay? You cannot put all the packages inside the same workspace. It depends. It depends on what you are working, okay? So let me show you. On the Catkin workspace, you have to put the code that goes inside the robot. So it's a code that will run inside your robot. You are sure that this has to run. Then the simulation packages of ROS, they don't have to run inside your robot, isn't it? You know, because for what? I mean, simulation is just for my desktop while I'm testing, but not on the real robot that will run on the customer's facilities, yeah? So that has to go into the simulations workspace, and so on. So the notebook that you saw before goes on the notebook workspaces, and then data sets, you have to put here, AI results here, etc. That's not the matter. For today, we are going to use only the Catkin workspace and the simulations workspace. So let me close all the other. So only those on the source directory. And then we just received a message on the chat from Wadong Hu that says that he is so excited, he's in China and now it's 1:23 a.m. So thank you very much, Wadong, for your attendance. That's an honor that you take so much effort to attend our live classes. So I hope that we can deliver a very good material and you are learning a lot. Of course, that applies to all of you. Okay, guys, please don't get don't feel like I don't understand that you are making also an effort. But that one was quite impressive. Okay, so let's continue. Then, so we are going to create our packages, the one of control in the Catkin workspace and the other one on the simulations workspace. So how do we do that? Well, we need to issue commands. So let's open a shell, a terminal. For that, we go to Tools, then select Shell. A new window here appears, so let me put it here. And then we are going to go, here it says, to the Catkin workspace source and create this package. Okay, so you can copy this command from here and then go to the terminal. First, change to the Catkin workspace /source. Remember to do that. That's very, very important. That's very, very important. Let me repeat. That's very, very important. Many people does it in their home or in other directories, so make sure that you are in this directory. Now you can issue the command for creating the package. It's Catkin create package, the name of the package, in this case ROSbot patrol, and then ROScpp. Issue that, and then it's created. So if you go here to the IDE, you can see that has been created here with a few files in the inside and directories by default. Okay, so that's being created by this command. Now let's open another terminal. So we are going to use two. So this second one, I'm going to put it here and maybe make it a little bit smaller. And then in this case, we are going to create the package for the simulation. For that, we need to go to the simulation workspace /source and then create this package, this command for creating a package. So let's do it. Let's go see this simulation workspace /source. Remember, you have to go to the simulation workspace. Why? Because this is a package that is going to contain our simulation. Okay, so that's why we are not using the Catkin workspace, but the simulation workspace. Okay, so then we issue the command. The command is the Catkin create package, ROSbot patrol simulation, and then the dependency depends on ROS CPP. Okay, yeah, whatever. Actually, we are not going to create any code today here, so don't worry about that. Okay, so it has been created. If we go to this here, to the IDE, to the simulation workspace, then source, then we have here ROSbot patrol simulation directory. Okay, so that's the one that has been created. We have another one, ROSbot Husarion, that is one that has been created by default. When we created this ROSjet from zero, then it included already this Husarion, description, gazebo, many other applications here that you can play with them. Okay, so yes, that's there for you. Okay, so let's go and then let me see here. Then I have a question here from Nikhil that says, sir, can you send your dependencies to... okay, I don't understand your question, Nikhil, so if you can elaborate a little bit, I will be happy to answer you. And then let's go. So then Saktibel also is asking if it is possible that I can do this on my PC, because in Development Studio I have only basic account. Yeah, of course. What I'm teaching here is just basic ROS. I mean, it's nothing related to your specific to our specific system, the ROS Development Studio. It is just that we recommend you that you use this because you can practice with me. I don't know what you have in your computer, so probably a lot of problems will arise with dependencies and with other problems usually happening. So that's the reason why. And everything. Sorry, I'm checking here, having some problems in the connection. Check that everything is correct. Okay, so let me see here. I have some problems, so let me see. Okay. So, well, so far so good. I think that you are following, yes? So, we have here, so we have created both packages. Then let's continue. Then what we are going to do is to create first the simulation part. So what we are going to do is to get the wall that we are going to launch, and then we are going to launch this simulation so we can start working with it. So for that, so let's go to the package that we have created, this one, and then we are going to create a directory which is going to be called walls, and then there we are going to create a file, model wall, and we are going to populate it with this information in this link here. Okay, so let's do it very quickly. You see, instead of doing through commands, let's do it through the IDE. That is easier and faster. So here in the IDE, I'm going to go ROSbot patrol simulation, and then I'll do right click and then new folder. It's called, then the name, it's going to be walls. So create walls, and then here it is. Then inside walls, select walls, and then do right click and say new file. And then in this new file, we have to put the name of the file that is called model model.wall. Okay, so model.wall here, model.wall, and then save it. It's automatically open here for us with an empty thing. So let me rearrange this a little bit so I can have more space. And let's see. Yes, okay, so let me put it like that. So that's now it's empty. Now let's populate this. Where is the content of this wall? Well, we have put this in this link that you can right click and open on a new tab. So you're going to see here is the model wall. It's a file that has been created by Adam. It's another person from the Husarion team, and then we are going to use his file from here. So if you click on this model wall, then the whole thing will show. So you can select this, all this, and actually it's a long space. It's a long. Let me see if there was an option here to copy everything. Let me see. Yeah. So you copy everything and then you go here to the file and do paste. And that's it. Let me check that no strange characters, they have been copied. Let me see, and everything it's okay. Okay, so it's automatically saved, so we have our model there. Then now, the only thing that remains is that we send our, let me check the PDF, that we launch actually. Oh, okay, no, wait, we had to create a simulation, yeah, the simulation mapping file. So let me go here back to the ROSbot patrol simulation, and then we need to create a launch file. For that, we need to first create the launch directory and then inside it, the launch file. So let's do a right click here on the ROSbot patrol simulation, then do a new folder and then call it launch. By calling it launch, yes, it's going to contain our launch files for the simulation. Okay, so now again select this launch file, launch directory, right click and then say new file. And then this new file has to be called simulation mapping.launch. So I'm going to copy and paste to avoid mistakes. Oh, there is a white space, I copied, so I'm going to remove it here at the beginning and done. Now we have the launch file here empty. Then let's put the content of this. And here is the typical launch file for a simulation of a robot. So let me copy everything from the PDF, copy, and then I'm going to paste it here in the launch file. And you will say, oh yeah, but what it means, what is all that about? Yeah, well, this is just very, very simple gazebo code. So, I mean, it's a launch file for ROS, but it's the code that you need in order to launch a gazebo simulation. And then those are the typical parameters that you can provide to a gazebo launch, either to use a GUI, to start post, to use the simulation time, which wall to launch, etc. And then you specify here the file. So the empty wall, and then here on the argument you specify which world you want to launch, and we are selecting our world. And then finally you include the robot that you want to spawn inside the simulation, and then you launch it. So you provide the launch file that is already provided by ROSbot. So ROSbot already has provided us with this launch file, so we can spawn the robot inside the simulation. And then we have added this TF because we needed that for the laser in order to do a static transfer from the laser. I don't want to get into more detail for that. Okay, so now we have it. Let me check that we are not missing anything. I think that we can go and launch it. Okay, so in order to launch that, you can do a ROS launch, ROSbot patrol simulation, and then simulation mapping launch in a terminal, and that will work. Let me provide you with a simpler thing. It's faster, especially if you need to relaunch and so on. For me, it's faster. So it's going to the simulations menu here on top, and then choose launch file. So if you go there, then here a new menu opens. If you open the drop down, you have to select here your launch file, the one that we have selected, simulation, we have created, sorry. It's simulation underscore mapping. So you select that one and then press launch. By doing this, then a new window is going to open showing the gazebo environment, and the simulation is loading. So there is loading. Let me have some coffee in the meantime and check the questions. Okay, many questions there. I can see that Christian is dealing with them. And I can check that in the meantime. I see one question from the Mr. Peluche Do 94. He would like to know the differences between the different folders. So the source, the debug, the build, the source, it contains your code, everything that you are putting in there. It's all the code that you are developing, so you type. Then on the build is where some so it is used during the compilation time as directory for storing things that you are going to need. And then the results are stored into the debug directory. So the final results, the program that you are actually launching, it's on the debug directory. And why you are working on your source, that's why, because we need to create our code, and the code goes always on the source. Then we have here a problem with, says, there is a problem in the, let me see if I still, yeah, because I'm connected to the robot. So this is my error. Okay, so let me disconnect from the robot. Okay, so let me launch it again. So I'm going to launch it again. So no, don't worry. So I was doing tests prior, and then I forgot that I was connected to the real robot, and then so that got confused. And here it goes. There's similar. Oh, I still have the same problem. Okay, so let me see if I have missed anything here. It says spawn model scripted. Then there is a problem with the GZ server, and it's a problem with the gazebo master URI. Okay, yeah, yes, I think this is a problem of the network, that because I was connected to the other. Yeah, I think it's that. So let me close it and launch it again. Because here there is nothing more. So let me check. So ROS topic list. Let me see. There should see nothing. Yeah. Well, just the things that of the simulation that have started. ROS topic list. Now it has died. Wait here. Now it should say nothing. Okay, yeah, correct. So yeah, so we are corrected here. We are connected here. Then it says, let me see, ROSbot patrol maybe. No, that this is everything is correct here. ROSbot patrol simulation walls, model wall, ROSbot patrol simulation and walls. Model wall, so it's correct. So let me check that I am doing this correctly. Sometimes there is just a misspelling error. So okay, wait. Here there is problem here. Okay, yeah, so and here is the model wall. Okay, let me launch it directly manually. ROSbot patrol simulation, and then the launch file simulation mapping. Okay, no, it's still failing, still fading. So it's let me see about the errors that we have here. It says it's like it's trying to connect to a place in order to get the model database. And it couldn't get the expected controller manager. Let me see. But I mean, it's very simple, this, so it doesn't make any. Okay, so that's like this. Here in the walls, is that correct? This is mapping. Then the ROSbot gazebo launch. Let me see here. ROSbot gazebo launch. ROSbot description. ROSbot gazebo. ROSbot gazebo here. So here it was saying something about the spawner of the controllers, the controller manager ROS interface. Okay, so here is where we are launching that. Let me do one thing. Let me just say about this. So I'm going to isolate this error. And okay, so that launch and the other one makes no, well, doesn't matter. So just the transform is going to be launched. So let me launch it and see if this is okay. But yeah, it looks like the problem is in the launch of the ROSbot. I mean, makes no sense at all to me. Okay, no. So it's a problem of connection here. It's a problem of connection. Let me see, this is already off. And it cannot get the model database. Let me create a new terminal from 0 and remove all the possible status of the terminal. And it's called ROSbot. What is ROSbot? What's the name? Is ROSbot Patrol Simulation. ROSbot Patrol Simulation. ROSbot Patrol Simulation. Simulation mapping. And then, so Adam is indicating in the chat that I have selected ROSbot as ROS master. Yes, I think that the problem lies there somewhere. But the thing is that I have disconnected already, so there is no ROS master, just the ROS here. So this machine, not the robot, and it's still failing. So let me check what is the ROS environment that we have. So is the master, is this master, host name is ROSDS computer, that's correct. Then let me see in the etc hosts, what do we have? Master, yeah, is this one. So master is this one. It's indicating that it's this one. Oh, and then let me see what is happening with the gazebo variables. So here gazebo says gazebo, what was complaining about is gazebo master URI. Wait for service has not been advertised. So let me see, gazebo master root is the local host. Maybe this has something to do with the IP6 that we have. Wow, that's big. That big, because all the IPs here are based on the IP6 format that we have enabled in order to connect to the robot. So that's it. You see that ROS is working on this computer using IPv6 IP addresses. So it's very those strange numbers that are here are IPs in version 6 format. And I think that maybe this is kind of colliding in some way. This is completely new, never experienced this in my case. So let me see if I can, it's because it's trying to check the database of models. And let me see if I can launch a simple simulation empty wall from here. So I have selected this empty wall here and then start the simulation. Let me see if that works. Because in this case, but it also and Liu Hun Li says here also cannot launch the simulation file. And then Wudong says that the words in launch file were mistyped. Okay, in my case, I don't know. Let me check. I checked it, but it is supposed that no. Okay, let me check. Okay, no, it's correct. This is correct. So let me go up and let me see if we are. So this is correct. So I don't think that there is a problem here in the PDF. What I think is that this is indicating some model of something, and then the gazebo is trying to connect to the models database, but it cannot because this IP address. I don't know if somebody is experiencing the same problem as I have. And then Adam Quarsik says change the ROS master on Usernet, but yes, so the ROS master is already here on the it's already pointing to this computer, so there is no problem here. Let me see. Stefan says there is a typo in the launch file number 11. Let me see. Already check it, but let me see. Oh, maybe it's just that. Maybe it's just that stupid thing. No, it can be this stupid thing. Okay, so let me launch it again. Let me try. Oh, wait. First, we have to kill this one here. That opened properly, this one. And then let me launch it here. So let's see if that works. Okay, so now, yeah, I think it was just a stupid thing there. Okay, and then just because of that, it's strange. Okay, so now if I have launched it from here, from the terminal, I don't see any simulation because the window of the simulation is not launched. You can go to Tools and open the gazebo window. So you can see there the simulation, and there it is. Without the robot, because I commented the robot on the other side. So let me close here, and then come here, remove the comments. And that's it. Then let's go and launch it again. Now I'm going to launch it from the menu because it's easier, it's cleaner. I don't have to use these terminals, and I can use the terminals for other things. So let me close this one here. I'm killing the simulation. I have removed the comments on the ROSbot gazebo launch, and then I'm going to choose launch file and the simulation mapping launch file. So thank you very much, guys, especially for Wodon who has captured the error, and very good, thank you very much. And also Stefan that has mentioned that, also very good, thank you very much. Thank you for your help, guys, on that, and we got it. So let's continue with this. Let's continue. So we got the simulation here, we got the robot and the wall that is here. So that's the wall that we are going to use, and the robot is over here. There it is, the ROSbot. And then so we have the simulation. Let's continue with the other things that we need to do. It's about creating the mapping code. So what we are going to do is to store all this mapping code, localization code, etc. into the ROSjet, into the ROS package that we have created inside the Catkin workspace. So all that code that we were touching about the simulation was in the simulation workspace. I can close it now because I don't need to change it. And then another thing here is in the ROSbot patrol package that we have created. So we have to create our code here for navigation. And as you are going to see, the code in navigation usually means just to create launch files. Just to create launch files. So it's launch files, configuration files, because the algorithms have been already implemented. So let's start by launching the mapping algorithm. Then for that, we go to the ROSbot patrol source, and sorry, it's the ROSbot patrol, and then not on source, but ROSbot patrol here. We have a source directory, but not there. Select the ROSbot patrol directory, right click, and then new folder in order to create a new directory called launch. Okay, so there it is. So there is where we are going to put all our launch files. So in this case, we need to call it gmapping-only.launch. So let's copy here and go right click to the launch and select new file. The name of the new file is gmapping-only.launch, and then let's copy the content here. In order to launch a gmapping, you only need to do this. All this is a very simplified system list of parameters for launching the gmapping algorithm that is already provided by ROS. So if you follow this for your own case, then for your own robot, you need to basically to copy everything from here. Take into account the same error. Don't do the same error I have done on the previous one. So here is the screen. There was a caret return. So remove it. Then for your own case, you have to copy. You can copy this and then play with the values. The only important ones, the basic ones that will make you start with your own robot are those. This remap, in case that your scan is published, your laser is published in another topic. So right here, the name of your topic that is published in the laser. Then the base frame, you have to specify your base frame. The map name, you can leave it like that. And the other frame, it depends on your robot in which frame it is publishing. Usually, most of the times, is autumn. Is the same, so you can keep it. And then those values, they depend on your laser and so on. But don't worry too much. Try like this and see what happens. Then afterwards, if you need more explanation, the other parameters, they are a little bit more tricky, and then you need to go to the ROS navigation stack documentation, or check our online course that we explain all those parameters and how to use them and how to modify. Okay, great. So we have the G mapping only, and then yeah, you have some explanation here about what I indicated, and then we are going to create also a move base package. What is the move base? The move base is the part of the ROS navigation stack that it's allowing us to create maps and make the robot move following those maps, and at the same time that is avoiding obstacles. Okay, so we are going to need that in case that we need to make the robot move autonomously. So basically, when you require navigation, you need three things. One thing is the mapping, another thing is the move base to follow the paths and avoid obstacles, and the other one is the localization that it's here a little bit beneath. Okay, we are going to see it in a minute. Then let's create this move base, even if now we don't need it for the map. Actually, we don't need it for the map, but okay, let's create it like this. Yeah, so we'll have it done. Then, so let's create another launch file that is going to be called movebaseonly.launch. Copy, and here go to the launch file directory where we created our G mapping, and then right click, new file, and then paste the name. Movebaseonly.launch. So those are launch files that are launching in a separate way each one of the different parts of navigation, so we can decide which one depending on which situation. Okay, so what do we have to do in order to launch the move base? Well, this is the code here, so let's copy and let's review it very, very quickly. So copy that and go to the newly created file and paste it. And let's modify this carriage returns also. Please don't do my silly mistake. And here I think I have repaired everything. Okay, great, so we got it. So basically we have to launch this move base node that is provided by the ROS navigation stack. So for your own robot, do the same. Even if it's different from ROSbot, it's okay, but do the same. And then here we are using some already existing parameters, some specific some that they work, that are required in order to configure the move base. The move base has a lot of parameters, a lot, and then I'm not going to explain them here. So go to the navigation online course that I mentioned, and then you will have them there explained. But the only ones that we are going to modify are the ones from the global cost map params that we are going to create in a minute. So basically this launch file is launching the move base with those parameters loaded. So let's continue. So which parameters do we have to create? Well, those ones, the ones that we are explaining here. And so these are parameters in order to modify a little bit the cost map, the global cost map that this move base is going to use. The cost map, it's a map that is indicating the places where the robot has obstacles, and those places where the robot cannot get in. And then we have two different types of cost maps, the local one and the global one. So here we are modifying a little bit based on the Husarion's recommendations to use those parameters for his specific robot. Actually, I think that those parameters are quite good and quite enough, maybe too big a little bit, but they're okay, so you can also use them into your own robot if it is not very much different than the Husarion's one, than the ROSbot. So let's copy those. Let's create a YAM file. Okay, for that we need to do something extra. Okay, so we are going to create a file that will contain those parameters, so they can be loaded by the file that we have just created in this line. In this line is loading this. So for that, usually we put the parameters into a config directory. So we need to go to the ROSbot patrol, do right click and create a new folder called config. Okay, then once you are there, we need to create a file that is going to be called global cost map params.yam. The format of the files of configuration parameters, it's format called yam. Okay, select this config directory with a right click and then new file, and provide this name, global cost map params.yam. You have to provide that name because on the launch file we're indicating that a specific name, you know. So if you provide a different name, it's not going to load afterwards and so on. We'll have problems like I had. Then what else? So here we are going to put those parameters that we received as the optimals for the ROSbot. So you can copy and paste here. You are going to see if you start, actually this is wrong because those parameters, they need to be indented. Otherwise there's going to be a problem because this indentation in the parameters means that those parameters, they are included inside this workspace. So if you put at the same level without the indentation, you are going to be in trouble. So because the system will not recognize as belonging to the previous workspace. Okay, so yeah, I was saying those parameters, let's use it, but you will see that when you apply the ROS navigation stack to your own robots, you are going to spend a lot of time tuning your parameters in order to get optimal results. Otherwise, you are going to get that the navigation more or less works, but then you have to fine tune. So the thing is that we have those parameters done, and now it's time to launch the file for doing the mapping. Okay, so we are going to create this specific launch file. Actually, we could also launch directly this gmapping only file, and that's okay. That's okay. So it's going to launch this launch file, and then the gmapping is going to start. But we have included in this other launch file the keyboard teleop, so we can move the robot around and create the map. And let me see, yeah, so let's do it then. Let's do it. So let's create this other launch file that contains the launching of the gmapping, the move base, and the twist teleop keyboard that will allow us to move the robot around. In order to move the robot around, we don't need the move base. We have included here because you can use this for exploration, for example. So you can provide goals to the move base while the robot is doing a mapping. So you can make that the robot creates a map automatically without the teleop. But we are not going to use it here today. So this, even if it is included. Okay, so just clarifying, not to make you confused. Okay, so let's create this file, running gmapping.launch. So I'm going to copy that name. Going to the launch directory, right click, new file, running gmapping.launch. Okay, then the code is what I mentioned, is to launch the gmapping launch file that we created, to launch the move base launch file that we created, and then launching the twist teleop. So let's copy everything and put it there. So there it goes. And yeah, so we have it. So let's launch it. We are ready to launch. So how do we launch a ROS program? You know already, yeah? So it's ROS launch. The name of the package, in our case, is ROSbot/patrol. And then the name of the launch file that we want to launch is this one, running gmapping. Actually, let's do one thing, guys. Let's go here to the running gmapping and comment this move base, because otherwise we are going to be wasting our CPU with so much work for the gmapping. So you can add this comment, you know, those characters here, or just delete the whole line. I don't want to delete it because I think that we are going to need it afterwards. So just comment this, so it's not going to be launched. Okay, so we don't waste our resources on that. Okay, so let me go back again. So ROS launch, ROSbot patrol, name of the package, and then name of the launch file, running gmapping, the one that I just modified. And let's launch it, and then the system for creating a map should start. Coffee. Here it goes. It's starting. And here we have a couple of people more attending. Mev Javin from India also. Wow, another person from India. Ni hao. And also we have Rikant from India. Hello. And then we have another person, 521, written in kanji, 521. So I'm attending robotic class later morning. Okay, so welcome also. Okay, so we have here the mapping running, but we don't see anything. We need to launch the ROS in order to visualize the map. For that, go here and another terminal and then launch the ROS. So how do you launch ROS? Like this. And then we have the ROS that has been launched, but where is the screen? We cannot see the screen here. It doesn't appear. Yeah, because that's a web environment. So if you were practicing this in your computer, you will see the window of ROS popping up. But in our case, it's not there. We have to go to Tools and then select Graphical Tools. In this area is where we are going to see any pop-up application that appears here on this web environment. And there it is, the ROS, but this, you see this screen is very small, so I'm going to detach from here and put as a new tab. How do you do that? Clicking on this icon, first icon, and then it's going to disappear from there and then show here on my another tab. So remember that I have here this other tab. Here is where I have my program running and everything, and then the ROS on this other one. I'm going to do a double click on the title to center the application. There it is. So now it's occupying the whole screen. This part, I don't need it. And I'm going to add the robot and the map. So let me go here to the add. So I want to visualize the robot and the map. So we have to add here, then go on this list and look for robot model. It's on the bottom. It's robot model. Here it is. Select that, and there it is, our robot model. It is there. Okay, great. We have our ROSbot there. Now let's add the map and see if the map it's been created properly. So add, and then go down, down. Here, map. And now it doesn't show anything because we had to configure the topic. So go to map here and select topic. Here, click on the right hand side of the topic. There is a drop down menu, select map, and then press enter. And there it is. So that's the map that is being created. Okay, so this is the part that has been created so far. Let me move a little bit, but we are going to move fast from here. So if you go to the shell where we launched the map, the mapping, you see that it's providing some information, so on. Remember that we can move the robot because the keyboard teleop has been launched here. So if you select this terminal, remember to have the focus and you see the prompt that is blinking. You have to see the prompt blinking. Then once you have the focus, then you can move the robot by pressing some keys. So let me show you the simulation because I'm moving the robot at present. So there it goes. So I press some keys, and the keys are, I don't remember which ones. So for example, to move forward is the Y, sorry, the I. Then to stop, press K. So I'm pressing K. Now the robot has stopped. And let me put this a little bit smaller. So remember that always has to be focused in order to capture your key. Okay, so now I'm going to turn right with the J. So I'm pressing J, and then it's turning a little bit slow. but it's turning. You can see that it's turning, okay? And then stop with K. So the map has been constructed better in these areas and so on. So you can keep moving around. We are not going to do that because it's too much, it's too long, and it's going to take a long time. But you see the how it works, okay? So far so good. So now we have created our map. We are happy with it. Let's imagine that we have moved along everything. Then we want to save this in order to use it later for autonomous navigation. So we need to save. So for that, we need to open another terminal. So go to Tools, Shell, and then select here. So we are going to save the map. Where are we going to save it? So let's go and create another directory here in the ROSbot patrol. So create another directory that is going to be called, let me see how we go, maps. Okay, so we are going to create it, maps. Okay, so go to with this other, you can do it directly on the terminal if you want. So let's do a ROS cd ROSbot _ patrol. It's going to take us to this directory. Then here create mkdir maps. Then it go inside these maps, and now we are going to call for saving. How do we call for saving the map? So here is the command, okay? Is rosrun map server map saver, and then -f with the name of the map that you want to provide to your map. So you can safely copy this, come here and paste it. So what it's doing is calling the map server, the one that here it is running, and telling, hey, save us your current map with this name. So it's going to do it. It's taking a little bit, I don't know. Yeah, but it's going to do it. Yeah, so here it goes. Okay, so now here you can see on the IDE that we have a new directory called maps, and if you open it, you can see the 2 files have been generated by the map. Okay, we got it. Then we have some questions there, and Adam, he's helping. Thank you, Adam. And Adam is also from the team Husarion. Okay, so thank you, Adam, for supporting us. And some person with a strange name, like in Russian, says, can I just rename the package? It's very bad idea, as Adam is saying, yeah. Then if you create it wrongly, then what? Yes, that's a typical mistake, to create wrong the names with different, yeah, because of mistakes or so on. Then the best option for beginners, the best option is to start over again, really, because the other way is too much complicated. You are going to mess it completely. Okay, so now we can close this program that is running here, select that one, and then Control-C in order to close it, because now we have the map. So we are going to use this map to localize the robot and make the robot move around autonomously. Okay, so let's go. Almost there. This is almost done. So we don't need this wall anymore. And so this is called the AMCL. This AMCL is the package for localization of the ROS navigation stack. So let's go and create another launch file called AMCL only, and that launches the AMCL. So for that, again, I'm going to the ROSbot patrol, launch directory, right click, new file, AMCL only.launch. So that's the new file that is going to launch the localization. Then here we select the launch file here that we are providing, and it's very typical also. So the only thing that you need to do to modify for your own case is this one. That's the topic of the scan where the laser is being published, the odometry frame that usually is the same, the type of odometry that usually is a differential drive like this one, and then the base frame ID also. Base link is also very common. So that's it. And those two more, then check the documentation for those. So that's it. Then we have that. then the only thing that remains is to launch everything. So we are going to create a final launch file that launches the move base to move the robot around, then the AMCL to localize. Then we are going to remove this teleop twist because we don't need that in order to move it, because we want the robot to move by itself. And then the map file, so we are going to launch the map server, but in server mode. So it's not going to create map, it's going to provide the map that we have used. And here is where we specify which map we are using. Okay, so this is the final launch file that contains the whole navigation stuff for your robot. So it will be able to move around in the map that you have created. Okay, so let's go and create another launch file, this nav ROSbot launch. So for that, again, let's go to the ROSbot patrol package, launch directory, right click, new file. Then it's nav ROSbot.launch. Okay. And then now we copy this content that is the one that I have just explained. Almost there, guys. So let me correct those errors. And yeah, so I'm done. Then let's continue. Long Yuan says, where can I find the PDF file that contains all the instructions? It's on this chat that you are on the top. Just go to the top and you will see a link to get this PDF, so you can get it there. Okay, so we are there and let's launch it. So now let's launch it. So this is the command. So it's ROSbot patrol and then the last launch file. And actually, let me remove that one about the teleop twist. So let me remove that one. If you don't remove, doesn't happen anything, okay? Just it's going to consume some resources. So I don't want it, so I'm going to remove. And that's all. So let's launch it. Now in this terminal, I'm going to launch this new launch file that I created. The command is roslaunch, ROSbot_patrol. And then it's running, it was called nav ROSbot. Nav ROSbot.launch. And there it goes. So now this is the whole navigation system. And here it goes. So we have a problem. It's not a file. Let me see. Nav ROSbot. Okay, yeah, I missed one S. That is why we have to use always autocomplete, tap. I recommend that. I thought that I was going to be moving faster typing, but not. So there it goes. So now we have everything launched, and if we go to the RBIS, we will see that our robot is there. And then now we can provide with, okay, some problem here. Let me see, invalid syntax. ROSlaunch XML, let me check. Oh yeah, here still there is another one that I missed. There it goes. Yeah, as I mentioned another time, I'm very prone to this. So I always doing those silly small mistakes, and yes, and it's taking a lot of time for me to find them. It's my drawback. What can I say? What can I say? Okay, so everything is starting here, the AMCL, the map server, the move base, and yeah, the three elements. Remember, the move base for path planning and obstacle avoidance, the AMCL for localization, the map server is the one providing, showing the map. Okay, then you can forget about those errors. Those errors are not really errors. They are just small not synchronized systems. But then at some point they are retrying, so at the end they synchronize, and we got it. Okay, so yeah, let's add something extra so we can see in the particles of the localization particle filter that we are using here. So the particles are going to show us where the localization system thinks that the robot is at present. How do we do that? Go to Add, and then move on the menu down until you see Pose Array. Pose Array. Select that one, Okay, and then let's open the pose array and configure the topic again here, and then go to the drop down, select particle cloud and enter. There we go. So now the robot thinks that it is there, but actually is in another place. So it's not correct for that. And we are going to see that very easy if we add the laser to the visualization. So let's add here, and let's search for laser scan. Laser scan, here it is. So you select laser scan, okay, then it's been added. Now we have to open it and select again the topic. For the topic, we are going to select the scan topic. That is the one that is providing us with the laser. And as you can see, the laser scan is being shown there. And let me put it a little bit bigger by selecting here the size and changing it to 0.05. So now we can see better. Yeah, so you can see that it's misaligned. You can help the localization system by using the 2D pose estimate. So you can select here 2D pose estimate and then provide it. It's around here, the robot, if I remember. So you click drag and drop more or less, and then it's going to resynchronize. Okay, it's not properly oriented, so we can do it again. The location I think is more or less, but the orientation more like this. Okay, more or less. Okay, great. So now we can provide with goals. So we can make the robot move automatically from this location to another one by itself. How? By clicking here on the 2D navigation goal. You click here, and then you provide another place where you want the robot to go. For example, here. Remember that the map has not been finished. So now it's a little bit constrained, the locations where it can go. Otherwise, it will get lost. Okay, so let's make it easy. But if you have the whole map, it doesn't matter. You can select any place. So here, we click here, then I select the orientation that I want to have, and then remove. And now the robot is going to start to move, as you will see. You see, it's rotating. So here, let me get it closer. Okay, there it goes. It's rotating in order to go to that point. Also, let's add another thing. So let's add the path that this robot is trying to execute. So we click here on add, and then select go down until we find the path. Path, here it is. Then the path is being there added. Let's open it. And now let's go to topic and select the global one. So here we have move base global plan. So select that one because it's the global one. And you can see that it's this green thing here. Okay, there are too many particles. So let me go and remove the pose array. So I'm going to disconnect the visualization. So that's going to be easier. And now the robot is trying to follow that path in order to reach the goal. Take into account that the robot is still not completely fully localized. So that's why the particles are so dispersed. And at the beginning it was kind of the local. Actually now it's very well localized. And the particles are starting to converge into a more closer location. And there it has recovered the position and it's going towards the goal, the final goal. Okay, so you can see now that also the lasers detected by the robot, they are very well aligned with the current map. So the robot is quite well localized on that. Okay, so now you have a robot that can move autonomously in your area, wherever the area that you are. So that's for the simulated robot. Now we can connect to the real robot. So in case that, so let me show you how to connect very, very quickly. It's very simple. So first of all, you have to have, this, you have to have the robot with the drivers for the laser. You see that it's rotating, okay? That means that has been activated. So they have to be rotating and publishing into a topic, into the scan topic. And then afterwards, you have to have the drivers for the motors that has been also activated, the ROS driver that is provided by Husarion also. So you have to have both things activated by default and publishing in ROS topics. So we are ready to go. Then what else do we do? What do we do is to go here and press on the real robot and then connect to the robot. So let's connect to the robot. This option is only under payment, okay? So maybe you don't have that now, but you can see how it works. It's under payment is very, very little price. It's just 9 euros, very, very small price. Then we need to provide the robot name and the robot URL. Where do we get this? Those data are published by the ROSbot into a web page server. So if you have your ROSbot connected to your Wi-Fi, that is my case. So this is my Wi-Fi, the one that I am, and this is the IP address of the ROSbot. Then the ROSbot publishes on the port 3000 this server. And this server is the one that is providing us with that information that the ROSDS is requiring. It means that robot name, sorry, where it went? Where did it went? Okay, so I don't know where it went. Let me close it and let's open it again. So, and here I'm going to turn it off because I was doing some tests before. I want to start from scratch. So you turn it on here and then you get here the username and here the URL. So I'm going to copy the URL here, that one, and go to the ROS Development Studio here, provide the robot name that is Husarion, and then the URL that I have just copied, and then connect. Then in some seconds, the system should connect to the robot, and that's it. Then it shows which ROS master you want to use. Whoa, here. Which ROS master you want to use. Either this ROSDS computer, this one, or the Husarion. So now my terminals, my system, is now working on the real robot. So let me close this one. So I can launch again I killed the ROS, damn it. So I will have to start it again. Okay, so now what I want to show you is that if I do a ROS topic list, we are going to get the topics from the real robot. So those are from the real robot, and we can, for example, I can send a command to the command bell and then make the robot move. So if I send a command ROS topic pub in the command bell, is a twist, and then make the robot rotate, for example, like 0.5. So now you have here the robot that is rotating. Let me move the coffee, no, please. And then I'm launching the command. Then the robot, if everything is working properly, then the robot should move. As you have seen, it has moved correctly, directly commanded from the robot. The problem, it doesn't turn because I have launched one single command. So for that, in order to make it turn, I need to make a rate of 10. Then if I launch it rate of 10, then the robot is going to launch and start rotating directly. Oh, I cannot believe it. The robot ran out of battery just now. Okay. I mean, that has been like this, working fully battery for many hours, and I forgot completely doing some tests. So I am sorry, but you only saw it for a few seconds. I wanted to show you directly on the ROS how we can capture this data and create the map also there. Unfortunately, we are not going to be able to do that right now, but you got the idea. Okay, so basically that's it for today. I wanted also to allow you to connect directly in case that you have a paying version of the ROS Development Studio, to connect to this one and control yourselves. But well, that's story for another day. Then let me see if you have any questions. So I will be here for 5 minutes more answering your questions and some surprises also. Let's see. So what do we have here on the chat? We have then the last thing that says okay, no. So I have this guy with the Russian name. Can you tell me how can I pronounce your name? I would like to actually call you. And then Adam says, this is strange. No, it's not strange because I was doing many tests before the class and then I forgot to connect this directly to the power. So it's completely gone, the battery. So the battery doesn't go. Then we have here another question from Theodore that says, hello, sir. First of all, thank you and thank you your team for providing so much information about ROS. Our pleasure. I would like you to ask if it is time to transition to ROS 2 since the 2020 release is on the horizon. Yeah, well, it depends. So I have answered these questions all the time. So it depends on what you want. If you want something fast, like we have seen here, then no. And then you want to do experiments and you don't want to care too much about ROS. So the less as possible about ROS. If you want to dedicate more, for example, to do experiments about SLAM algorithms, I don't know, about making this robot interact with people, about deep learning with this robot. So ROS is a tool for you, it's not the main goal. In that case, just stay with ROS 1 because ROS 2 is still missing some things in order to be so robust as is ROS 1. Then, on the other hand, if you want to experiment and you want to put your robots to the top, or you require that your robot works with some features of ROS 2, like real time or security or decentralized system. So in those cases, then use ROS 2, but you are going to spend a lot of time making it work. It's a lot more difficult, has less documentation, the community is smaller yet. Okay, so this is growing, this is going forward, but it takes some time yet. So I hope that answers your question. Then, any other question, guys, there? So if there are no more questions, we have been for 1 hour and a half due to the problems that I have with the stupid mistake of the carriage return. And then we don't have any more questions, so you can have them there. Let me explain you about the next live class that is going to be next week. Okay, on this one, we are going to deal with a very common problem recently in ROS, which is how to use Python 3 with ROS. So this is a question that many people ask us, and some of you have proposed to do this live class in the chats, in the comments, in the videos. So you mentioned, hey, what about this? Can you do a live class? And then we say, wow, that's a super cool subject that we had to solve ourselves for some of the examples. For example, you need to use OpenCV3 libraries based on Python 3 or OpenAI libraries for reinforcement learning that only work on Python 3, or the new version of TensorFlow 2 that works only on Python 2. So for all those cases, then, and you want to use ROS, then how can you do that? That's the subject of the next live class. That's going to be super interesting. It's a little bit complicated, but I mean, you are going to follow step by step how to do that, and you are going to master. We are going to do a simple example, and then you can apply this to your own projects. Okay, and then we have here another question. Oh, it just was deleted by Meg Javin, the Chinese girl from China, that about multiple robots. You mentioned that is we have already some live classes about using multiple robots. Check our list of live classes on YouTube and you will find a couple or 3 of them explaining how to do that. Then 521 says nice. Okay, 521. Then Gudong Hu says, sir, why do we need different workspaces, simulation, Karkin workspace? Why not jump all into a single workspace? That's a very good question, because of organization principles. So what happened on my previous work is that we had everything in the same workspace, and that was That was a mess because you had some packages. We had so many packages, and then at the end you had to make those packages work on the real robot. Then which you had to do kind of cherry picking of the packages, which ones go there, and then you forgot, and then so it's a mess, you know. So you're mixing things that don't go together. That is why we decided for our product to separate between what goes for simulation is just for simulation. Then when you are done with simulation, you can forget about that, and it cannot interfere into your ROS code. So if you have problems in the simulations, errors in the simulation workspace, you don't care because your calculating workspace is working on the robot properly, so you can forget about those errors because they are not affecting. But if you got those on the same directory, then you cannot compile, you have to deactivate some of them, it's a complete mess. So basically it's organization. And guys, I think we have to leave here, and that's all for today. So I hope that you enjoyed, that you learned a lot, and that you are going to keep pushing your ROS learning. See you next week.